Hello everyone. So today let's solve the problem 867, right? So this one, transpose matrix, right? So let's see what the question states here. So here we are given an m into n integer matrix. See here, we can clearly see here we are given a m into n integer matrix. We have to return its transpose, meaning this one, an n into m matrix where element at a comma j in the original becomes j comma I, right? So again, so we have been given m into an integer matrix. We have to return its transpose in the sense n into m matrix where element at I comma j in the original becomes j comma I, reverse, right? So in the result, right? So let's consider this. See here, they have given us wonderful this thing, the diagram as well as the definition part here. So the transpose of a matrix is the matrix flipped over its main diagonal, right? So switching the matrix row and column indices. Simple. Just give me a second here. See, so this one they have strictly mentioned here, right? So this row, whatever 241 we have, so this one will be considering this one in the column basically. See here, 241 changes to 241. We are just transposing it, right? So same thing goes with the row 2 and row 3 as well. 10 5 11 we have in the second row, so the second column consists of 10 5 this one, 10 5 11, and the third row consists of the 18 minus 7 and 6, and the third column consists of, now after transposing it becomes 18 minus 7 and 6, right? So this is nothing but the transposing. Simple, right? So now let's come to the first example. Same goes with the first example. See here, we have 1 2 3, so we have 1 2 3 4 5 6 and 7 8 9. So after transposing it becomes, so this first row will be 1 this one 1 2 3, so this turns into the column, right? So this one 4 5 6 becomes 4 5 6 second column. The third row becomes 7 8 9, so this one will be third column basically, 7 8 9. Simple, right? So this the output will be basically for this, it will be 147 256 and 369. See here, 147 25 258, this one, sorry, not 6, yeah, this one is 258 and 369, yep, 369. So this will be the output. Same goes with the example 2 as well, man. Similarly, so you can just consider this one in the same way for the example 2 as well, right? So this is it for the question. They have given us wonderful examples, right? Just for the sake of understanding. Also they have given us definition here along with the this one diagram, right? So this is fine, man. Now let's do one thing. Let's quickly discuss the approach followed by the this one complexities, and then let's write the code, right? So one thing, so here we'll be going with a DP, right, to solve this particular problem. So we'll be going with a DP, right? So we'll be treating the result as it this one DP table of size n into m, right? And we'll fill each cell from the input, nothing but this is a table filling DP style. We'll view where the state of DP of ji is directly computed from the matrix ij, right? So this is fine, I believe. Just give me a second here. So this one, if I say it, rather than let's consider this one, let's do one thing. Let's consider this one, the first example here. Let me scroll this one, just give me a second. This first example, let's consider this one. So what we'll do, so we have m equals 3 and n equals 3, nothing but rows equals 3 here and the columns equals 3. So this is nothing but m rows and this is nothing but columns n, right? So first we will create the DP result of size 3 into 3 because we have 3 rows 3 column 3, right? So first we will create the DP of size this one 3 into 3. This is fine. Now for I equals 0, let's see the iteration part. So we have to go with 3 iterations, right? Row 0, row 2, row 3. So this is row 0, this is row 1 and this is row 2, total 3, right? I equals 0 means it starts from the this one 0 index, right? So we will read the values 1 2 3 first. So this one 1 2 3 and place them on the DP of 0 0 equals 1, DP of 1 0 equals to 2, DP of 2 0 equals to 3. Nothing but, as I have said, the rows we are keeping this one on the columns basically, 1 2 3. So this is nothing but this one, what do we call, DP of 0 0. So this one, this is nothing but DP of 0 0, DP of 1 1 and DP of DP of 1 0 and finally DP of 2 0, the value 3. Same goes with this one, what do we call, I equals 1 and I equals to 2. So we'll be placing 4 5 6 here. So this is nothing but DP of 0 1 this is nothing but dp of 1 1, and this is nothing but dp of 2 1, right? So again, finally let's go with the final iteration for I equals to 2, nothing but the row 2. So we will be placing column here, this one 7 8 9 finally. So this is nothing but dp of 0 2, this is nothing but dp of this one 1 2, and this is nothing but the dp of 2 2, right? So this is fine, I believe, right? So finally we will return dp, which is basically 1 4 7 2 5 8 and 3 6 9, right? So the output that we got here is 1 4 7, this one, let me give this one in the array, 1 4 7 and 2 5 6 2 5 8, right? So and finally we have got 3 6 9, so this one will be 3 6 9. This is fine. So 1 4 7 2 5 8 and 3 6 9. So this is the output that we got here. This one, this is the output that we got here. So this is fine, 1 4 7 2 5 8 and 3 6 9. So the output that we got here is this one, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct in this case, right? As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, right? So what will be the time complexity here? The time complexity would be because of m into n, right? So time complexity would be because of m into n, because we have visited each input cell exactly once and do because of one work per cell, right? So this is fine. So what would be the space complexity here? The space complexity would be because of m into n as well, right? So this is time complexity and this is space complexity, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be because of m into n and because of m into n respectively, right? So this is because we'll be going with the result array of size n into n, space complexity I'm speaking of. So we'll be going with the result array of size n into m, which is required basically nothing but the output space, and here time complexity because we visit each input cell exactly once, right? So we have already discussed this one, and we do because of one work per each cell or per cell basically, right? So the time complexity and space complexity would lead to pick of m into n for both respectively. So this is fine, man. Let me delete this one. Now as we are completely familiar with the approach and the complexities, let's start writing the code, right? So first thing is so let's assign this one, let's get the number of rows in the input matrix, and also let's get the number of columns in the input matrix as well. M and n, we have already discussed this one, right? M equals, here let me go with a matrix, this one, let me copy this one, let me go with matrix dot length. So this is fine. N equals, again I'll just go with matrix of 0 dot length. So this is fine, man. Now let's do one thing. Let's allocate the result dp with the dimensions n into m. So this is nothing but the transpose size. So this one I'll just go with int result equals, so this one will be new int of n and this one will be m basically, right? So this is fine, man. Let's iterate every row index I of the original matrix. So let's go with a simple for loop. So this one will be for int I equals 0, I less than m, so this one will be I plus plus. So within the for loop, what I'll be doing, let's loop over each input column, right? So I'll just go with for int j equals 0, j less than m, so this one will be j plus plus. So this is fine. So within the for loop, so let's go with the dp relation, nothing but result of ji equals matrix of ij, right? So this one I'll just write it, result of j I equals matrix of I and j, right? Simple, right? So we are left with only one thing here. What we need to do, we have to return the completed transpose matrix, nothing but we have to return the result, res variable that we have considered, right? So I'll just go with return res. This is fine, right? So this is nothing but the final transpose turned into a matrix. So this one, we are just outputting the result, right? So this is fine. Let me format the code once and let me hit the run button. So here you can clearly see, right, the sample test cases are getting passed. So let me hit the submit button quickly. So yeah, you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, right? So the code works absolutely correct on this case. So yep, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.